All right, welcome back. This is the AWS AI hardware. This is going to be our next section. But before we get started, remember to hit the like button, subscribe, and share this with anyone you know taking the AWS Machine Learning Associate exam. So, AWS AI hardware, from virtual servers to custom silicon. So, the evolution of artificial intelligence workloads demands more than traditional computing infrastructure. While AWS offers numerous managed AI services like SageMaker for streamlined machine learning workflows, many organizations require granular control over their compute environment, particularly when training massive data models or serving predictions at enterprise scale. Amazon EC2 bridges the gap by providing resizable compute capacity in the cloud, but with a twist: specialized instance types designed specifically for AI workloads. These aren't your typical virtual servers. They're equipped with cutting edge GPUs and custom designed silicon that transforms how organizations approach machine learning infrastructure. So, the hardware landscape. All right. So, AWS has strategically developed a comprehensive hardware ecosystem for AI, spanning from proven GPU solutions to revolutionary custom chips. This progression represents years of engineering focused on one goal: delivering superior performance at per dollar while reducing environmental impact. Traditional GPU based instances like the P series, think P3, P4, P5, and the G series, think G3, G4, G5, G6, leverage NVIDIA's proven architecture. These instances excel at parallel processing tasks inherent in deep learning, with costs ranging from moderate, think $1 to $3 an hour for a G5 X large, to substantial, think $12 to $24 per hour for a high-end P series instance. However, AWS recognized an opportunity to innovate beyond standard GPU offerings. Enter AWS Tranium and Inferentia. These are custom silicon designed from the ground up for machine learning workloads. Okay, Tranium. So, Tranium represents AWS's bold entry into purpose built training silicon. It's designed for deep learning models with 100 billion or more parameters. Tranium chips power TRN1 instances that promise up to 50% cost reduction compared to comparable GPU instances. A single TRN1 32x large instance costs approximately $21 an hour, but deploys 16 Tranium accelerators from massive parallel training capacity. AWS Inferentia. So this focuses on the other end of the machine learning lifecycle: inference. These chips optimize for high throughput, low latency prediction serving. So the LNF1 and LNF2 instances powered by Inferentia deliver up to 4 times the throughput improvement and 70% cost reduction compared to traditional GPU inference solutions. An LNF2 48x large instance runs around $14 an hour while providing exceptional inference performance. Both Trania and Inferentia carry an additional advantage. They represent the most environmentally efficient options in AWS's AI hardware portfolio, and it appeals to organizations prioritizing sustainability alongside performance. So, hardware and practice. So, understanding these instance types requires hands on exploration through the console. The process reveals both the power and cost implications of specialized AI hardware. So, if you navigate to the instance selection, you can access the EC2 services in the console. So, you can go in the console. Let's see, you click Launch Instance. And this will open up the instance creation wizard where you can configure your virtual servers. All right. And so, in this, these are free tier. Let's go all the way down to, let's say, P3. All right, so this would be P3, right? From here, you can have your virtual servers, name your instance descriptively, something like ML training demo to identify its purpose. And looks like that's not there. Mac Ultra Metal, no, that's not there. Anyways, then you can get intelligent recommendations that AWS provides through the Get Instance Type Advice feature. If you click that option, all right, that's Amazon Q. Console of Cold. Where is it? Advanced. Get advice. There we go. Click that. All right. And from here, you can see different selectors, right? See web app, cache, data warehousing, etc. Okay. You should see, let's see, use case, e-business, e-commerce, business intelligence, priority, CPU. Okay, hold on. Deep learning. There we go. Okay. And then from there, gaming, e-commerce, let's say data science. So deep learning should be the one, right? Or you could do deep learning training. Yeah, that could also work, right? So the system will recommend appropriate instance families like G5G for general GPU or more specialized options for intensive workloads. All right. So you see these P6, G5G, C8GN, C7GD. All right. And you can click on here to see the recommended families. All right. And you can filter for specific technologies. For direct exploration, you can use the search functionality to filter by instance family type. All right. Um, so let's see. Okay. So instance family. And let's see TRN. Oops. TRN1. All right. And then to see all the Tranium powered options, or you can do INF2 for Inferentia instances. So the console will display each instance's specific uh, requirements and capabilities, as you see here, right? Alongside the hourly pricing. So, and you go over here, see $21 an hour, $24 an hour, $1.34 an hour, all right? And this is critical given the costs involved. And then you can understand the cost reality. As you browse through the options, the pricing becomes more immediately apparent. So you can see the TRN one, it is about $21 an hour. Then you can see and you could go in, see the INF2 can show approximately $14 an hour. So these figures would underscore why careful planning and controlled usage are essential. Leaving these instances running accidentally can result in significant unexpected charges. Then you have a critical safety note. Resist the temptation to launch these instances casually during exploration. The console makes it easy to click launch, but doing so with high-end AI instances can quickly accumulate substantial costs. Instead, use the console for research and planning, launching instances only when you have specific workloads ready and cost management strategies in place. Okay. Integration with AWS services, right? So specialized instances don't operate in isolation. They integrate with AWS's broader ecosystem. So something like SageMaker can train jobs and specify the instances for custom model development. And then containerized workloads via ECS or EKS can leverage this hardware for scalable inference serving. So the integrations extend to emerging AI frameworks as well. So Hugging Face's partnership with AWS can enable LLMs to function efficiently on the custom chips, while AWS Neuron can ensure compatibility with popular frameworks like PyTorch and TensorFlow. So hardware choices, right? This isn't the best one, but this gives you an idea of what they look like, right? So selecting the appropriate AI hardware requires understanding your specific workload characteristics. Training massive transformer models with billions of parameters benefits from Tranium's parallel processing power, potentially justifying the higher hourly costs through faster completion times and lower total cost of ownership. Inference workloads demand different considerations. High volume, latency sensitive applications benefit from Inferentia's optimized architecture, while smaller scale inference might run cost effectively on standard GPU instances or even CPU based options. For organizations prioritizing environmental responsibility, Tranium and Inferentia offer the lowest carbon footprint among AI capable options, an increasingly important factor in a lot of corporate sustainability initiatives. Let's go back to cost a little bit. Okay. So the hourly cost of AI optimized instances demands careful cost management strategies. Consider using spot instances for fault tolerant training workloads. So this can potentially reduce costs by 70 to 90% for development and experimentation, right? You can also use SageMaker Studio Lab that provides a cost controlled environment without direct EC2 instance management. Implementing monitoring and alerting to prevent runaway costs Make sure AWS Cost Explorer and CloudWatch are there to track your spending patterns and sending alerts when usage exceeds expected thresholds. For training workloads, consider SageMaker's managed training jobs with automatic instance termination rather than managing the EC2s directly. And the future of AI. So, AWS's investment in custom silicon represents a broader industry trend towards specialized AI hardware. Tranium and Inferentia demonstrate how cloud providers are moving beyond simply hosting traditional hardware to developing purpose-built solutions that optimize for specific workload patterns. This hardware evolution enables new possibilities in AI development, from training models previously considered computationally prohibitive to serving predictions at scale that support global applications. Understanding these capabilities and their appropriate applications becomes increasingly crucial as AI workloads grow in sophistication and scale. The key lies in matching workload requirements with appropriate hardware while maintaining cost discipline. Whether leveraging proven GPU solutions or embracing AWS's custom silicon, success depends on understanding the performance, cost, and environmental trade-offs that define modern AI infrastructure decisions. So that's going to be the end of this one. Next, we'll probably go into AWS Lookout, anomaly detections. But before we get going, hit the like button, subscribe, and share this with anyone you know taking the AWS Machine Learning Associate exam. Thank you, and have a good day.